Welcome to today's Explainer. We are jumping right in to decode nature's 10 deepest mystery anomalies. We're going to look at mind-bending scientific research that literally challenges our fundamental understanding of reality. I'm incredibly excited to take you through this because we're looking at things that, well, they really shouldn't happen. But the data proves they absolutely do.
Okay, let's dive right into our roadmap. We're covering 6 areas today: the hidden rules of nature, biology's quantum machinery, the logic of particles, the observer effect, rewriting time and reality, and finally, the unfinished universe.
Section 1. The hidden rules of nature, challenging everyday reality. To start our journey, we kind of need to take everything we expect from classical physics and just throw it out the window. We expect the universe to behave like a predictable, ticking machine, right? But the crucial point here is that everyday concepts, like a leaf falling from a tree, or even the solid chair you're sitting on right now, actually hide these bizarre, completely contradictory rules when we look closely enough. The foundational layer of reality completely defies basic logic.
Moving on to Section 2, biology's quantum machinery. Life is not an accident.
So in 2015, MIT physicist Jeremy England radically changed our perspective on this. For decades, going all the way back to Schrödinger, the classical view was that life is this rare, fragile anomaly actively resisting thermodynamic disorder. But England's framework mathematically proves something wild. He showed that atoms subjected to a sustained energy source will automatically reorganize to dissipate that energy more efficiently. Basically, self-replication isn't some cosmic accident. It's a thermodynamically inevitable optimal strategy. You aren't just a lucky break. You are exactly what matter does when it's exposed to starlight for billions of years. 99%. Just let that number sink in. That is the near-perfect 95 to 99% solar energy conversion efficiency of photosynthetic proteins. This was actually measured by Professor Graham Fleming's team back in 2007. Think about what this actually means. Life operates quietly on quantum mechanics. To hit that staggering 99% efficiency, leaves maintain delicate quantum coherence, essentially existing simultaneously across multiple pathways in warm, wet environments around 37 degrees Celsius. And it lasts for picoseconds, which is thousands of times longer than classical physics says it should. But plants definitely aren't alone here. European robins literally navigate by sensing a tiny 50 microtesla magnetic field using quantum entanglement right inside their retinas. And deep inside your own body, enzymes utilize quantum tunneling, passing straight through impossible energy barriers to accelerate chemical reactions millions of times over. It's like biology is running a secret quantum engine.
Section 3, the logic of particles, mathematics breaking down.
Okay, if biology bending the rules was crazy, wait until you see how quantum mechanics completely shatters basic math and physical properties. Consider the classical pigeonhole principle. It's literally basic counting. If you put 3 objects into 2 boxes, at least one box absolutely must contain 2 objects, right? Well, in 2016, Yakir Aharonov's team proved the quantum pigeonhole effect. Using weak measurements to avoid disturbing the system, they placed 3 particles into 2 boxes, and in 100% of their trial runs, shockingly, absolutely none of them shared the same space. 3 particles, 2 boxes, 0 overlap. Mathematics itself just breaks down.
And if math breaking isn't enough, what about physical identity? In 2013, Tobias Denkmeyer's experiment demonstrated something called the quantum Cheshire cat anomaly. Just like the cat in Alice in Wonderland leaving its grin behind, nature can pull an object and its essence completely apart. They extracted partial information and actually found a neutron traveling on one path while its magnetic moment, its core-defining property, was traveling on an entirely different path.
Which leads us to this fascinating question. If a particle's spin can exist where the particle itself is nowhere to be found, what is holding your own properties tightly together right now? This staggering separation of properties forces us to ask a really profound question about the stability of the chair you're sitting on and the very body you inhabit. Are you actually guaranteed to stay in one piece? Section 4. The observer effect. Watching changes reality. We can trace this next anomaly from a 1993 theoretical question by Elitzur and Weidman straight to a physical reality. They asked, does detecting an object fundamentally require touching it? Classical physics says yes, absolutely. But by 1994, a Los Alamos team achieved a 50% detection accuracy without direct contact. And by 1996, that accuracy improved beyond 85%. Scientists detected an object's presence without a single photon actually touching it. Look at that 85% success rate from 1996. Information about an object's location was successfully gathered without any physical energy signal passing back and forth. No interaction whatsoever. If detection doesn't require interaction, you have to wonder, what is observing you right now without leaving a single trace? The paradox of observation itself is just fascinating. We have the quantum Zeno effect, which shows that continuously watching a system can freeze it entirely. It literally halts its decay. But, as Saverio Pascasio proved in 1992, if you tweak the timing, you trigger the quantum anti-Zeno effect. By simply tuning the frequency of your observation, you severely accelerate the system's destruction. Just by watching it at a specific rhythm, you force it to break down faster. Nature literally changes its pace based on how often we look at it. Now, for a long time, physicists really hoped this weirdness was just in our heads, a gap in our knowledge, But the PBR theorem in 2012 completely crushed that hope. Voted the most significant quantum foundations paper of 2012, this theorem forces us to accept that the wave function is an objective physical reality, not just a subjective tool tracking human ignorance. This leaves scientists trapped with the extremely uncomfortable question of what physically triggers its collapse when we measure something. The universe literally exists in a state of probability until observation forces its hand. Section 5, Rewriting Time and Reality, History, Bias, and the Future. This strange behavior even extends to the flow of time itself. You might know the classical Mpemba effect, where warm water sometimes actually freezes faster than cold water. But theoretically predicted in 2020 and proved in 2024, the quantum Mpemba effect is much, much stranger. It shows that a system's historical pathway matters way more than its present state. A trapped ion starting further away from equilibrium actually finished its journey faster than one starting closer. It completely breaks the rule that the shortest distance takes the least time. History matters more than current position. And speaking of how history shapes reality, let's shift to a macro scale for a second. Nick Bostrom and his colleagues identified the anthropic shadow in 2010. They realized our existential risk data is dangerously skewed, and the reason is simple. Surviving mass extinctions is the only way to leave a record of them. Extinct civilizations cannot record their own destruction. So we are basing our safety on data that is fundamentally flawed by an absolute selection bias. We're blind to the true nature of catastrophic risks because we only possess the survivors' data. But perhaps most baffling of all is Yoon Ho Kim's 1999 experiment. It showed the quantum eraser retroactive effect. In this experiment, completely erasing which path information in the future retroactively rewrote an interference pattern that had already been recorded in the past. Modern physics is totally split on why this happens. The retrocausality hypothesis suggests information actually travels backward in time. Meanwhile, the many worlds hypothesis argues that cosmic branching just creates the illusion of an alteration. Either way, an action taken tomorrow can literally change the physical trace left yesterday. Mind-blowing. Finally, Section 6, The Unfinished Universe. What's next? We've journeyed through biological quantum mechanics, broken math, and retrocausality. We've seen that observation forces reality to take shape, and that choices made in the future might literally redefine the past. So as we wrap up today's explainer, I want to leave you with this final provocative thought. If the future can rewrite the past, what part of your own reality is still waiting to be decided? Thank you so much for exploring these incredible mystery anomalies with me. Keep questioning the reality around you, and I'll catch you in the next explainer.